All right, let's dive into an element that you've probably never heard of. Why? Because it doesn't exist in nature. And it's so incredibly powerful, it literally creates its own light. This is the wild story of curium.
Yeah, you heard that right. It sounds like something straight out of science fiction, but it's totally real. Some forms of this metal are so intensely radioactive that they physically heat up and glow a dull red in the dark. It's like a self-contained elemental fire. So, what exactly is this stuff?
To really get curium, the first thing you have to understand is that it's an element that completely defies nature. This is a substance born entirely from human ingenuity inside a lab.
So here's the key takeaway. Curium is synthetic. You can't mine it. You can't find it anywhere on Earth. Any tiny bit that might have existed when our planet first formed has decayed away billions of years ago. We have to build it, basically atom by atom. And its name, fittingly enough, is a tribute to the pioneers of radioactivity themselves, Marie and Pierre Curie.
Okay, so what about that glow? Well, it comes from the sheer intense heat it generates just from its own radioactive decay. One of its common isotopes, Curium-242, pumps out about 3 watts of thermal power from a single gram. That is a huge amount of energy coming from a tiny little piece of metal that's just sitting there.
And to put that number into perspective, think about this. We use plutonium-238 to power our deep space probes like Voyager and the Mars rovers. It's kind of the gold standard for that stuff. Well, Curium-242 is about 6 times more power dense, an absolute powerhouse. So how on Earth did we even manage to create such an extreme element in the first place?
Well, the story of curium, maybe not surprisingly, begins during the frantic race to build the atomic bomb, the Manhattan Project in World War II.
Curium was first cooked up inside the Manhattan Project way back in 1944. Its very existence was a top military secret, just a byproduct of all the intense nuclear research happening at the time. It wasn't until after the war was over that its discovery could even be mentioned to the public. You know, before they settled on the official names, the scientists had their own private jokes about these new elements. The process of actually separating these incredibly radioactive substances was so maddeningly difficult that they nicknamed them pandemonium and delirium. Kind of tells you what they were going through, huh?
And here is one of my favorite little bits of science trivia. The world didn't learn about this top-secret element from some stuffy scientific journal. Nope. It was revealed on a kids' radio show called Quiz Kids when one of the discoverers, Glenn Seaborg, was a guest and just kind of let it slip. What a bizarre debut for such a serious discovery. So, how do you actually make it? Well, it is a painstaking process. You start with the lighter element like plutonium. Then you stick it in a nuclear reactor and just bombard it with particles. This forces the atoms to absorb those particles and transform into something heavier. After all that, you're left with just a microscopic amount of curium that then has to be chemically sifted out from everything else.
Okay, so you go to all that trouble to create this glowing, difficult, secret metal. What for? What's the point? Well, believe it or not, one of its most incredible uses is millions of miles away, on the surface of another planet. This little device here is called an APXS, and you can think of it as the field geologist for the Mars rovers. Tucked safely inside is a tiny pellet of Curium-244, and that little pellet is the key to understanding the entire story of Mars, a story that's written in its rocks.
The science behind it is just so elegant. The curium spits out alpha particles, which are basically just tiny helium nuclei. When these particles slam into a Martian rock, they knock some energy loose from the rock's atoms in the form of X-rays. And just like a fingerprint, the energy of those X-rays tells the rover exactly what elements are in that rock. It's brilliant.
And get this isn't some newfangled technology. Curium has been our go-to element for this exact job for decades. Every single NASA rover that has ever touched Martian soil, from Pathfinder in '97 all the way to today, has carried a tiny piece of curium with it, helping us piece together the history of water and maybe even life on the red planet.
But for all its incredible utility in space, back here on Earth, curium represents something far, far more menacing. It is, without a doubt, one of the most toxic substances known to humanity.
The danger really comes down to this one critical distinction. See, the alpha particles that curium emits can't even get through a sheet of paper, let alone your skin. So outside your body, you're pretty well shielded. But, and this is a huge but, if even a microscopic speck of it gets inside you, those exact same particles become tiny little wrecking balls tearing your cells apart from the inside out. That's the paradox of curium. The very thing that makes it a perfect tool on Mars makes it a devastating poison inside the human body.
And here's the truly insidious part.
Once it's inside you, your body gets confused. It actually mistakes curium for calcium and deposits it directly into your bones. And from there, it just sits, irradiating your bone marrow for decades, shutting down your ability to make blood and triggering all sorts of aggressive cancers. It is a silent, relentless, and horrifying poison.
Which, of course, raises the obvious question. Why on earth do we bother making something so incredibly dangerous? Well, because for all its risks, curium is a key that unlocks some fundamental secrets about our universe.
Its scientific legacy is just immense. We use it as a stepping stone, a target to smash other atoms into, to create even heavier, even stranger elements that push the very boundaries of the periodic table. It helps us understand the fundamental forces that hold atoms together. It teaches us how to better manage the nuclear waste from our power plants. And of course, it lets us do geology on Mars.
When you get right down to it, curium really embodies the double-edged sword of nuclear science. It's a source of almost unimaginable power and knowledge, but it's one that demands our absolute respect and containment. In the end, curium kind of forces us to ask a much bigger question. Our ability to forge new types of matter, to literally build atoms that the universe itself didn't put here, that's an incredible display of human intellect. But with that almost godlike power comes a profound responsibility to manage our creations wisely.